Hello everyone, I'm welcome all on Data Phoenix webinar. Today we will speak about infrastructure, and with us Andrei Cheptsov. He is founder and CEO at dstack, and he will talk about what limitation Kubernetes have and how using dstack you can improve and use Kubernetes in a better way for training and deploy GenAI models. So before I give the microphone to Andrei, I want to say that you can ask a question in our Slack channel. Today we a little changed the place where we start to collect the questions. So please join to our Slack channel, and you can find events channel where we have a thread about this webinar and where we collect all your questions. So please join there, and yeah, I give the microphone to Andrei to start his presentation.
Awesome. Thank you, Dmitry. Thanks for having me. Pretty excited to present my thesis today. As Dmitry said, I'm the founder and CEO of dstack, the company that is building the open source project called dstack. And this is also the main reason why I'm speaking about managing infrastructure for AI. The project we are working on, the dstack open source project, we built it to make it easier to manage AI infrastructure. And today we'll talk about, well, in general, like what are the challenges of managing infrastructure, why one would want to do that. And of course, we'll mention Kubernetes as one of the standards for managing infrastructure. And we'll also talk about dstack and how it compares to Kubernetes. So it's going to be a pretty introductory level of the presentation, but it could be quite interesting for folks that actually interested in learning more about like what are the challenges of managing infrastructure, and then why tools such as Kubernetes and dstack are needed, how they compare to each other. A little disclaimer here. We're gonna compare dstack and Kubernetes and talk about the advantages and disadvantages, and I'm going to present my personal opinion on that matter, and I'm very happy to discuss this topic also and drag it like outside of these presentations as well. So feel free to share your feedback, questions, and comments, and where you also have different opinion in the Slack channel, which Dmitry mentioned, and I'll be more than happy to also take the discussion there as well. Right, here we go. So we'll start with the first question, which is why anyone would want to manage infrastructure. There are many ways today to run software and also run AI without a need to manage infrastructure. Like the simplest example is Lambda function. Take AWS cloud provider as an example. It allows us to run functions without us managing the infrastructure behind. So what it means is that the cloud provider manages this infrastructure for us. We don't really have to think of the network, of the hardware, of the container orchestration. All we need to think is what code we want to run, and we let the provider do the rest. This is pretty powerful concept, of course. It's called serverless, and it doesn't mean that there are no servers. Of course, there are servers behind. It means that somebody else manages these servers. So the infrastructure is managed for you. And this comes, of course, with many limitations. And if you are familiar with Lambda, then you know how many limitations actually Lambda function puts, like in terms of like what hardware you can use, what memory, and what kind of code you can use. Even being flexible, there are many limitations. Not just what you run and how you run, but also how it is priced and how it scales. And serverless is a great technology to start with, typically, but as you scale, there are so many nuances that you really may want to understand how it works behind. Another good example of serverless is services such as OpenAI, especially in the AI area. When you are using a model, for example, that is provided by OpenAI or similar provider, you also consume this service as a serverless service. Means that you don't manage any servers behind, which means that the provider actually manages this infrastructure for you. And the easier it is for you to use such a service, the more complicated it is for the provider to manage it. So, and that's the compromise. You compromise their simplicity and ease of use for other things that you cannot manage. And here comes the question. Okay, so then why one would want to manage own infrastructure, and especially in the case of AI. So there is no single answer to that question. There are many different aspects, and I'd love to basically go through all of them, even though they are totally separate ones, and some of them are just orthogonal to each other. First one is, of course, the control. For example, if you are using the OpenAI model, you depend entirely in terms of the model behavior and how it works internally on their provider. The provider promises you to offer that model, but you cannot have any control over that. So imagine that your business depends on the behavior of the model. Then there is a risk if anything is changed by the provider. You don't have that control. So basically, you put your business at risk. And this is why more mature companies actually want to have a control over the behavior of the model and how it works inside, over the infrastructure which is used, over the protocols that are used. Second thing is customization. Again, we'll use pretty same example all the way. With OpenAI, there is a way to customize it, but there's a significant limit to that. There are many things that you cannot customize. You cannot customize a model. You can just fine tune it to a certain extent, but you cannot change the model significantly. And this could be one of the reasons for managing own infrastructure, if you'd like to have a control over the model behavior and being able to customize models or serve entirely custom models. Privacy is also an important topic, even though serverless providers have a lot to offer in terms of the privacy. Of course, when you manage your infrastructure yourself, you have a lot better leverage there. And this is also one of the main reasons why companies choose to manage infrastructure themselves. Then cost is a interesting aspect. When you are using a serverless provider such as OpenAI or Lambda, typically they offer you pricing per usage. Means that if you're using the server, the little of the server, if your usage is very little, then you pay very little. And the more you use, the cost actually grows linearly. And it means that if your usage is very high, then your cost will grow linearly, and at a certain point, it's going to be too much. And this is why, for example, if you are using the most advanced model by OpenAI, then sometimes costs grow too high, and you need a way to manage those costs. And this is where managing infrastructure yourself can help you, because if you manage this infrastructure yourself, then you don't have to pay premium for the vendor for managing this infrastructure for you. Means that if you can leverage tools to manage it efficiently, then you can drive the cost down significantly. And this is an important factor for serving AI models as well. And finally, dependencies. When you are using a serverless service, you highly depend on the particular model or on a particular provider. And if something changes, you'd like to switch between the provider, there is a risk that it's not going to be an easy one. When you are managing the infrastructure yourself, you have entire control over the dependencies, and you can choose which tools you use, which models you use, etc. So those are the reasons why companies decide to manage the infrastructure themselves. And then next, we're going to talk about the challenges. Even though here in the slide I have two main points here, managing infrastructure is associated with many challenges. There's a lot more than to these challenges. But when I reflect, I think of these two as most let's say difficult problems to deal with. When you are responsible for managing infrastructure, probably the most important thing is reliability. When you are using serverless provider, then their provider is responsible for for how reliable the service is, and they have to because you pay the premium, they have to invest a lot of this money to making the infrastructure highly reliable. So if you decide to manage the infrastructure yourself, of course, the first challenge there and primary challenge you deal with is reliability. And whenever you decide about the tools to use for infrastructure management, reliability comes first, always. Second topic typically being discussed when infrastructure is being discussed is portability. So why is that? When you manage infrastructure, again, you don't want to be dependent on a particular vendor. And if you decide to switch their provider, then it's a big risk that your business will basically be hurt. That's why it is important when it comes to managing infrastructure to use tools that offer you portability. Portability means that you can switch between providers without losing anything. Right. So those are two challenges. Of course, there are many more. And maybe if we continue that list, I would also mention complexity. Infrastructure is a complex topic. There are many things to take care of. Like, for example, reliability. We can split it into network, hardware, software, security, and many things. That is why it's not something that you can handle entirely yourself. It means that you have to rely on tools for that, on the tools that reduce the complexity and abstract out this complexity for you. Right. And there's no surprise why Kubernetes is such a popular tool. If you haven't heard of it, Kubernetes is an open source tool, most common tool for managing infrastructure. And like I said, there's a very simple reason why this tool is so popular. It offers you reliability. So basically, it solves the scalability and all of the aspects that are important for managing your infrastructure. Then Kubernetes is portable, means that it is an open standard, and regardless of which provider you use, as long as the provider supports this standard, like the framework engine, you can rely on Kubernetes as a tool. I mean, of course, there are many nuances, and maybe we'll mention some, but maybe not into the very depths. Also, I would like to mention that one of the reasons why Kubernetes is such a popular tool is that it's open source, and it means that there is a community behind, and there are many tools built on top of Kubernetes. And this is one more reason why you can rely on Kubernetes, because even if one solution might not work perfectly for you, there are many others built by the community. Sometimes, of course, it creates more complexity than it solves the problem, but still, it is very important for such a tool that helps you manage infrastructure to be open source. So to recap, think of many providers: AWS, GCP, Azure, and many others. All of them are quite different. However, because they support Kubernetes, it empowers your DevOps team to reliably manage infrastructure. So that's a super powerful concept. Right. Of course, there are challenges of using Kubernetes. And of course, there are challenges of using Kubernetes for managing AI infra. And typically, when we speak about Kubernetes at like events, there are always people that come after the talk or during the talk and say, look, Kubernetes don't have challenges, like it's the best tool, and you just don't know how to use it, which is fair. However, I still like to basically have this discussion over like what are their challenges there are like that people see there, and I'm certainly sure that when it comes to AI, there are many things that are not optimal, and it is important to basically speak about these things. One thing which makes it challenging for using Kubernetes for managing AI infra is that in the first place, Kubernetes is built to deploy software at scale. So all of Kubernetes like primary concepts, they are about deployment, about scaling the infrastructure. And when it comes to AI, it's not always production deployment, or not only deployment. We'll talk about like what AI consists of in further slides, but basically there are many other things. You have to do development, you have to run and orchestrate tasks, which are not exactly the deployment workloads. And also when it comes to deployment, there are some nuances, like it's also GPU accelerators, basically, and also aspect in regard to like it's not just a workload, it's also a model. So there are many things that you have to deal with, and that's why typically teams not using Kubernetes directly, but actually use some other tools that are built on top of Kubernetes. So basically, just Kubernetes alone is not enough. And secondly, now today, like with the advance of AI and the great demand for GPU, there are also many more providers that don't even offer you Kubernetes, but they offer a lot simpler interfaces like programmatic API and SSH access and other stuff, which makes it really hard to use all those services because there is no such a thing as Kubernetes for that. And for those cloud providers, it's quite challenging to bring Kubernetes to make it compatible with Kubernetes, because Kubernetes is quite complicated thing. You basically have to implement the entire stack of Kubernetes to be Kubernetes compatible. So this creates quite a lot of problems there, which we'd like to talk about. So at the dstack company, we built a tool called dstack. It is an open source project which orchestrates containers just like Kubernetes. So in that case, dstack and Kubernetes, they are the same thing. They help orchestrate containers over the infrastructure provider, which can be any provider. One difference here is that dstack from the day one is tailored for AI development and deployment. So basically, on one hand, it's not just only deployment, but also development, which we'll talk about. And then it's like AI workloads are the first-class citizens. And I'll also mention in more detail what it really means. One thing that also makes it like different from Kubernetes is that if with dstack with Kubernetes, the cloud provider have to implement the Kubernetes stack to offer Kubernetes interface over the provider. In case of dstack, you don't have to do that. It is just enough to, on the dstack side, to implement what we call a backend that will allow you to manage infrastructure with a particular provider. So with dstack, there is a backend for AWS, there is a backend for GCP, Azure, Lambda, TensorDoc, VastAI, and many other providers that AI engineers actually use today to access affordably cloud GPU. And finally, of course, dstack is also open source entirely. And we'll now talk in more detail about like what dstack is, what defines it, and how and what exactly we mean when we say AI development and deployment. So if you look at dstack, there are 4 primary concepts that you basically that it helps with and that you have to understand in order to use dstack. First one is the most simple one is dev environment. You might be familiar with such a thing as dev environment. Dev environment is a let's say setup of a specific environment and hardware, typically something that you use with a interactive development environment, like an IDE, VS Code, PyCharm, or Terminal, or Jupyter Notebook, that allows you to interactively work with your code. And with dstack, this is the first-class citizen, which means that you can provision dev environments with dstack, and dstack will take care of all of it. And we'll talk about how this works also in more detail in further slides. Second is tasks. Tasks are also first-class citizen, and those could be batch jobs, fine-tuning jobs, like training jobs. In AI, you not only deploy stuff, but you also sometimes have to schedule long, very heavy jobs that you need to run in order to train a model or fine-tune it. Then services. Services is when you deploy something. And finally, we also offer such a abstraction as pool. Pool is a way to manage the life cycle of cloud resources, because unlike traditional resources, GPU resources are pretty expensive and sometimes are very hard to get. dstack offers this pool concept that allows you to easier manage the access to those resources. and you can arrange these resources into a pool. You can configure how they can be consumed, and then whenever you run dev environments, tasks, and services, you basically reuse this compute from those pools. Right. So here's an example of how dev environments work. With dstack, just like with Kubernetes, everything is declarative. You can define a dev environment declaratively. Means you specify the environment, like, I don't know, version of Python or base Docker image. You specify the resources that you need, what kind of GPU you need, like how much memory you need, whether you need an IDE, and then you run this configuration with dstack, and dstack automatically picks the right resources over the one of their configured providers, and then you can access it through the desktop IDE and work with that dev environment as long as you need it, and then release it, and then resources are released to either to a pool or to the provider, which makes it really convenient to do development for AI. You can easily switch between different kind of resources. Right now you need A100, tomorrow you need some other machine, and you always can use your desktop IDE with all the plugins that you want, or use a Jupyter notebook, and everything is declarative, means that everything is in code, and you can replicate it at any time with any provider that you want to use. Right. Second one is tasks. Just like dev environment, they are also declarative, and you can define many things there, like environment, like what commands to run. With task, you can also configure ports. Like, for example, if a task also has some I don't know, web application that requires that is required for the task, like it could be anything. dstack allows you to configure that as well. You also configure resources, nodes. This is also something that is to be released soon whenever you want to run a distributed job. And then you run that. dstack also takes care of the provisioning at all with a chosen provider. And then it also handles the port forwarding and other things like Kubernetes. But basically, it's a little bit more high level, and it's pretty useful for training and fine tuning. Like, for example, like in this particular animation, you see that you just define this fine tuning script. You can use any framework for fine tuning. You can use any base Docker image, and then you just run it, and it runs within the configured cloud. Right. Services. Services is what you're going to use if you want to deploy something. It could be a web application, it could be a model, it could be an API, whatever. Again, you configure their environment, you configure the required resources, commands that, well, you want to run. And great thing, just like with Kubernetes here, is that you can use any serving frameworks, because, well, dstack is just a container orchestration. It allows you to use any serving frameworks, any Docker images. You can even use any language you want. It gives you a lot of freedom. One cool thing that makes it useful for AI development is that you can not only configure what you want to run, but also, in case it's a model, you can configure the model mapping, and then dstack will automatically provide the OpenAI compatible interface for accessing that model, which is pretty cool, because, well, regardless of which framework to use, you can be sure that there is an OpenAI, like, kind of a standard for accessing any models that you deploy through dstack. Replicas is also something that to be released soon, that allows you to automatically scale that particular model or API across multiple nodes and regions. Right. Finally, pools, which I mentioned. As I said, because GPU resources are pretty expensive and sometimes are hard to get, it is important to manage their life cycle. So dstack allows you to book these resources, and then reuse these resources as long as you need them, and then release them. So whenever you run something with dstack, you have this provisioning policy. For example, you can say, okay, so reuse resources from the pool. If there are no resources in the pool, get me resources like either on demand or sport or some other things, some other options, and then dstack will first provision that resources, it will add it to the pool, and then you can run anything you want, be it dev environment, task, or service, using these resources from the pool. A good example when this is important is, let's say you have an AI project, and you know that you'll be working on that project for, let's say, a week or a month, and then you want to ensure that for all that time you need access to, let's say, 10 A100 machines. So with dstack, you can pre-arrange those machines into a pool and then reuse them, being sure that anytime you run something, resources are there ready to be used. But also you can run things like on demand. If you don't have resources there, you just run something and dstack can provision those resources automatically. You can configure idle duration, for example, saying, let's say, run something. If I don't reuse the resource again within an hour, release it, and then you don't pay. And by doing so, you can save a lot of money. And just also to give one more example, let's say you are using Lambda Cloud or some other provider, and you need for your project 10 machines. You can book them in advance, like 5 days in advance, or like 1 day in advance, and dstack will book it for you. Once they are booked, they are in your pool and they can be consumed at any time. So wrapping this up, and also to give you some rough idea what's going on inside dstack and how dstack actually works inside. There is dstack server. Dstack server is a piece of software which you can run anywhere, your laptop or in your cloud, anywhere. It's just a place where dstack stores the metadata and all the cloud provider like credentials. And then it also stores users and projects. You can configure multiple teams, and those teams will be like isolated projects there. With dstack, every project might have different cloud providers configured, and then you can use the CLI or API to run dev environments, tasks, and services. And dstack will use the basically configured backends to provision the infrastructure for you, and it also manages the state. In a way, it is similar to like Kubernetes. Just like with Kubernetes, you also have the CLI or API. But then you configure cloud backends like AWS, GCP, Azure, other providers. And based on what you've configured, when you run something, dstack provisions that infrastructure in those providers. And every task, service, and dev environment are associated with the Docker container, which dstack orchestrates. For services, dstack also uses such a thing called gateway. Basically, with dstack, it's quite easy to configure the ingress traffic, basically allow to access those services from the internet. You can configure like a domain. Dstack automatically set up their HTTPS SSL certificate. It also allows you to connect to any running workload through SSH securely. Doesn't matter where it is running. And that is it. Without, of course, going into much detail. So it's a very rough overview of how dstack works. It's just enough for you to run dstack server, configure backends, and then your team can use the CLI and API to run dev environments, tasks, and services. So it gives you everything, pretty much everything that you need in order to do development and deployment of AI models. To recap what we discussed today. So dstack and Kubernetes are both orchestration engines. If Kubernetes is a general one, which is mostly focusing on deployment, dstack is built in the first hand for AI projects. Secondly, dstack is more lightweight, means that it's much easier to integrate dstack with modern cloud providers. And dstack already supports many cloud providers, including TensorDoc, Vast, Lambda, and many other providers that don't even support Kubernetes. And there is an API to also extend support of dstack with other providers. So if you are interested in helping bringing support for more cloud providers, you are very much welcome. So having said that, happy to see if there are any questions. Also, if we have time for questions. And also, I'd like to maybe finally to mention that there's a link to the documentation where you can find more examples, like in some tutorials, how to use dstack, and also the link to the Discord channel where you can ask questions and engage with other dstack users, and basically stay up to date.
Yeah, Andrei, thank you for this good presentation and overview. Please join to our Slack channel and on the channel of events where we have the thread about this webinar, ask your question, and still folks come to our Slack channel. I have some question about the future and about integrate dstack with other systems. For example, if we want to use dstack locally and we have some local cluster with GPU and this cluster operate by Slurm, for example. Do you have some plans to integrate with such workflow managers for cluster, which are locally and possible to use it local?
Yeah, thank you, Dmitry. Great one. We have already a plan to allow you basically to connect your bare metal like machines to dstack, and this will be quite easy to do. So you would just need to have an SSH access to that machine, and then one command will let dstack automatically connect through SSH to that machine and install automatically the agent there, which will connect that machine to a pool. And then once you run that command, basically dstack pool add, and then you provide the host of your machine. Dstack will automatically add this machine to a pool. So next time you'll run something, dstack will see that machine in the pool, and it will basically use that to run those containers there. Please.
Yeah, but it's case when we have the some machine which we can use only for dstack. But if we want to share it for some other computing tasks, sometimes we need to have some queue for using this resource. And if we speak about not 1-2 machine, but 100 machine, it's I think a little harder to manage all this machine, and that's why we often use some Slurm manager for manage all this compute power.
Right. I just want to mention that basically what I'm saying, like when you connect one machine to dstack pool, you can do that for many machines. Imagine that you have a cluster of interconnected machines, like I don't know, 100 machines. When you connect them to dstack, they all are accessible through dstack. Means that if you run some distributed job, dstack will be able, just like Slurm, to run that workload over that cluster. And that's exactly what Slurm does.
Yeah.
And dstack will take care of handling the queue of jobs and tasks. And in that sense, this is how we see dstack will help you do what you previously did with Slurm, but have all of those features that dstack offers out of the box. That's one thing. Secondly, in some cases, there are also like teams that actually already use Kubernetes. Just for those teams, we already support Kubernetes, and we allow to connect the Kubernetes cluster to dstack. And for dstack, a Kubernetes cluster is just a backend, a Kubernetes backend, which means that now, if you do that, you can reuse that Kubernetes cluster either through dstack or through any other tools built with on top of Kubernetes, which makes it like a hybrid stack. Then you can use like side by side dstack and other Kubernetes tools.
Yeah, and if we speak about deploy model, like in production, and about scaling these models, do you support for now automatically scales and monitors which resource should be provided for a model which work in the production and serving by dstack? Or do you have some plans for this? Because when, for example, I have only one node, it will be better to have some parameters, in which case my infrastructure should scale.
Sure. And this feature is basically already planned for the next release, which will basically take place next week. So if you look at dstack services, what we add there will allow you to configure a range of how many replicas you actually want to allow for that service to use. And there'll be a default of how to auto-scale it based on the load, but we'll also provide a way to adjust the scaling mechanism. So you'll come up with some rules of how to scale it and downscale it and upscale it. So basically, dstack will offer you an interface to upscale and downscale any service that you deploy.
Yeah, I understand. Good. Please not miss your chance to ask also the question and join to our Slack channel and ask and write your question there. Still, for to do this, I have one question. You help to find more cheaper computer resource for your clients. But one the problem when you try to use different clouds, it's to send data between the different cloud providers. So how you solve this problem if, for example, I have my data sets which I want to use for training in AWS, but you find for me better price, for example, in I don't know, in Google or other computer providers. So how all will work in this case? Because sometimes the price of transfer data is very high.
Right. So yeah, basically, this is one of the challenges that we actually want to solve with dstack. So one of the key problems with the AI infrastructure is their compute. Because of this high demand for GPU, and because of that high cost of the GPU, there's a lot of scarcity of in the market, and GPUs is really hard to get. And sometimes you can see, for example, that in order to get your infrastructure, you basically compete for an order, like to NVIDIA, with other companies. And then what basically the leverage that typically like such a provider as NVIDIA is using is it offers you to make a commitment like on the size of the deal at all. So that's why companies such as like Meta and Microsoft, they are able to buy a lot of compute. And you as a startup or as a smaller company, you often find it impossible to basically sign a 3-year like reservation contract or like pay a lot in advance for basically buying that infra. So that's why infra is so hard to get, like GPU is so hard to get. However, what we also see that there are many smaller providers that actually buy that GPU, and there are many other, let's say, ex-crypto companies that have a lot of compute and which they throw into the market. And that's why we see a lot of compute providers, alternative compute providers. And that's why often it's much easier to get compute with a smaller provider than with dstack. And that creates, well, it solves the problem of accessing the GPU because, well, there are companies that let you get the cluster that you need. However, this cluster can be in some region, or you might have like basically like compute spread across multiple regions. So basically, I'm just explaining why this question is important and why it exists. And getting back now to your question, I wish there was a way basically to solve it like a silver bullet. There is no such a way. There are multiple challenges. One challenge is providers such as AWS, GCP, they have ingress fee. When any data is downloaded from outside, those providers ask you to pay. Means that if you run a lot of workloads, like a lot of run many heavy jobs within particular provider and region, means those providers push you to basically store this data there or replicate this data there. And there are no solutions like super convenient solutions for data replication yet, at least known to me. But for example, there's already providers such as, for example, Cloudflare that offer you, for example, R2 service that even though it doesn't replicate data for you, it offers you, for example, no egress fee. Means that you can download the data from that storage and don't pay for that transfer. So basically, it's free for you. And this is a great tool because then you can have those R2 buckets in the regions that you need, and you can replicate data there yourself. And then you can save on the data transfer. And some providers, actually modern providers, some of the providers that don't ask you to pay for the egress fee, which is cool. So it's another way to say that it is a challenging problem to solve. There are tools for that, but today you have to basically manage it yourself where your data is. And of course, in most scenarios, that means that you have to replicate the data where is compute. And if you are using compute in multiple regions, you have to replicate that data in those regions.
Yeah, I understand. Good. So I can say today, thanks for all who was with us on this webinar. Andrei, thank you for your presentation and sharing your knowledge, and I hope dstack will growing, and we will see and read more interesting news about your project. Hope in near future we will not only speak by internet and online, but maybe some time in the future we will do this offline. And thank you for all who was with us. We'll see you all on the next webinar.
Thank you, Dmitry, and thanks everyone who watched this. So I invite to the dstack Discord once more time. Looking forward to your questions, and yeah, have a good day, everyone.
Yeah, if you will still have the question after this video, after that you will check the dstack and try it, you always can ask it on our Slack channel or in dstack Discord channel also. So welcome to our chats, and we will happy to continue discuss with you all guys on our channels. Yeah, thank you.
Thank you. Bye-bye.